Background and history. Jet age ambitions. The X-15's role in advancing aerospace capabilities. 1. The X-15 rocket plane emerged during the jet age, driven by the quest to explore and understand the outer limits of atmospheric flight. 2. Its development was a collaborative effort between NASA, the US Air Force, and North American aviation. Evolution of aerospace research, from rocket-powered aircraft to space exploration. 1. The X-15 represented a crucial step in the transition from conventional aviation to the realm of rocket-powered, high-speed research aircraft. 2. The plane's design aimed to gather data on aerodynamics, materials, and human physiology at extreme speeds and altitudes. Human spaceflight precursor, paving the way for future space endeavors. 1. The X-15 laid the foundation for human spaceflight by pushing the boundaries of altitude and speed, providing essential data for subsequent space programs. 2. Its contributions were instrumental in shaping the understanding of the challenges posed by atmospheric re-entry. Historical impact. Supersonic pioneering, breaking the sound barrier and beyond. 1. The X-15 set the stage for supersonic flight, routinely exceeding Mach 1 and achieving unprecedented speeds for its time. 2. Its supersonic achievements revolutionized the understanding of aerodynamics and paved the way for faster and more efficient aircraft. Altitude records, reaching for the edge of space. 1. The X-15 set multiple altitude records, ascending to the fringes of space and providing critical insights into the challenges posed by the Earth's atmosphere. 2. These altitude achievements marked significant milestones in human exploration beyond the conventional boundaries of flight. Suborbital spaceflights, touching the edge of space. 1. The X-15 conducted suborbital spaceflights, providing crucial data on the physiological effects of space travel on the human body. 2. These suborbital missions contributed to the understanding of the challenges astronauts would face during future orbital missions. Historical milestones. First flight, inaugurating a new era of aerospace exploration. 1. The X-15's maiden flight marked the beginning of a series of groundbreaking missions aimed at advancing human understanding of high-speed, high-altitude flight. 2. The successful first flight set the tone for the X-15's legacy as a pioneer in experimental aviation. Piloted by legends, celebrating the aces of the X-15 program. 1. Renowned test pilots, including Neil Armstrong and Joe Engle, piloted the X-15, showcasing the elite roster of aviators who contributed to its success. 2. These experienced pilots played a vital role in pushing the X-15 to its limits and gathering invaluable data for aerospace research. Hypersonic achievements, surpassing Mach 5 and exploring hypersonic flight. 1. The X-15's ability to achieve hypersonic speeds, surpassing Mach 5, opened new frontiers in aerospace research and paved the way for future hypersonic vehicle development. 2. Hypersonic achievements provided crucial data on aerodynamics and thermal protection at extreme speeds. Technological advancements. Rocket propulsion innovation, powering the X-15 to unprecedented speeds. 1. The X-15's rocket engine technology represented a leap forward in propulsion systems, enabling the aircraft to achieve speeds unattainable by traditional jet engines. 2. Innovations in rocket propulsion were key to the X-15's ability to reach the edge of space. Thermal protection, shielding the X-15 from intense heat. 1. Thermal protection technologies were critical in safeguarding the X-15 from the intense temperatures generated during high-speed flight and re-entry. 2. Advances in thermal protection contributed to the feasibility of future spacecraft re-entering the Earth's atmosphere. Flight control systems, navigating extreme flight conditions. 1. The X-15's advanced flight control systems were instrumental in maintaining stability and control during high-speed, high-altitude flights. 2. Innovations in flight control laid the groundwork for the development of future spacecraft and spaceplanes. Challenges and risks. Aerodynamic challenges, navigating uncharted territories. 1. The X-15 faced aerodynamic challenges at extreme speeds and altitudes, requiring innovative solutions to maintain stability and control. 2. Overcoming aerodynamic uncertainties was crucial for the success and safety of each mission. High G-forces, testing the limits of human endurance. 1. The high accelerations experienced during X-15 flights subjected pilots to extreme gravitational forces, testing their physical endurance and resilience. 2. Mitigating the effects of high G-forces became a critical aspect of ensuring the safety of the test pilots. Atmospheric re-entry, overcoming the challenges of returning to Earth. 1. The X-15's atmospheric re-entry posed challenges in managing heat and aerodynamic forces, requiring careful engineering to ensure a safe return. 2. Overcoming the complexities of atmospheric re-entry contributed to advancements in space vehicle design. Future prospects. Legacy of aerospace research, impact on future space exploration. 1. The X-15's legacy lives on in the field of aerospace research, with its achievements informing the design and operation of subsequent spaceplanes and spacecraft. 2. The data gathered during X-15 missions continues to be relevant to the development of future hypersonic and spaceflight technologies. Hypersonic flight development, informing future hypersonic vehicles. 1. The X-15's success in achieving hypersonic speeds laid the groundwork for the development of future hypersonic vehicles, influencing ongoing research in this field. 2. Hypersonic flight achievements contribute to the ongoing pursuit of faster and more efficient aerospace technologies. Human spaceflight milestones, shaping the trajectory of human space exploration. 1. The X-15's contributions to understanding human spaceflight challenges played a role in shaping subsequent milestones in space exploration. 2. Lessons learned from the X-15 program informed the development of spacecraft for orbital missions and lunar exploration. Controversies and debates. Risk to test pilots, balancing exploration with safety concerns. 1. The X-15 program faced debates about the ethical considerations of subjecting test pilots to high-risk experimental flights. 2. Discussions centered around the balance between advancing aerospace knowledge and ensuring the safety of those pushing the boundaries of flight. Classified missions, speculation and secrecy surrounding certain X-15 missions. 1. Some X-15 missions were classified, leading to speculation and curiosity about the nature of these secretive flights. 2. The veil of secrecy sparked debates about the transparency of government-led experimental aerospace programs. Research priorities, evaluating the allocation of resources in aerospace research. 1. Debates arose about the allocation of resources to experimental programs like the X-15 in comparison to other priorities in aerospace research. 2. Discussions focused on the perceived benefits and drawbacks of investing in high-risk, high-reward endeavors. Additional information. Public perception, capturing the imagination of the public. 1. The X-15 captured the public's imagination, becoming a symbol of cutting-edge technology and human daring. 2. Its visibility in the media and public consciousness contributed to the popular narrative of space exploration. Test pilot community, the camaraderie and legacy of X-15 test pilots. 1. The test pilot community involved in the X-15 program formed a close-knit group, sharing a unique bond forged through their experiences. 2. The legacy of X-15 test pilots continues to influence the culture of experimental aerospace research. X-15 restoration projects, preserving aeronautical history. 1. Restoration projects aimed at preserving and showcasing X-15 aircraft contribute to the understanding of aerospace history. 2. These projects highlight the significance of the X-15 in the broader context of aeronautical and space exploration.